All right, guys, welcome to this page of the notes, and here's what we're going to start here on this page of the notes. We're just going to add one extra little wrinkle when it comes to completing the square, and this is it. In order to complete the square, hopefully what you've noticed in all of the previous problems is that my leading coefficient has always been a 1. And if you think, wow, I really don't remember that, just flip back through the pages that we've already done and look at all the problems we've solved, and you'll recognize that every single one of those, the coefficient in front of the x squared has been a 1. It's always been a 1. But that's not always going to be the case. Sometimes that leading coefficient is not a 1. The problem is it has to be a 1. In order to complete the square, you need that leading coefficient to be a 1. So what we're going to do here in the next several problems in the notes is we're going to take a look at how do you deal with that problem? If I wind up with something where the leading coefficient is not a 1, what are we going to do? What do we do? So, actually, I show you right here what we're going to do. If my leading coefficient is not a 1, I'm simply going to take whatever that leading coefficient is, and you're going to divide everybody by that leading coefficient, right? So my leading coefficient is A. I divide it by A. B divided by A, C divided by A, and 0 divided by A, or whatever's over there, divided by A. Just divide everybody by A, and of course A divided by A gives me that leading coefficient of 1, right? I'm going to force that leading coefficient to be a 1. So that's how these are going to work. Let's go ahead and try one together so you can see it in action. What I've got is a leading coefficient of 2. That is no bueno. In order to complete the square, it's got to be a 1. So we're going to do exactly what we just were shown above, and I'm going to divide everybody by that leading coefficient. And what it does is 2 divided by 2, of course, is 1. So I get my x squared and do the rest of them. Negative 12 divided by 2 is going to be a minus 6. 4 divided by 2 is going to be a plus 2. 0 divided by anything is just 0. And now we're all set. That is not a perfect square. Move it to the other side. Add b squared over 4. But whatever I do to one side, I gotta do to both sides. Alright, my b is a negative 6. Negative 6 squared is 36. 36 divided by 4, you guessed it, it's 9. Awesome. Leaves me with a 7. I need a minus 3 and a minus 3, which gives me x minus 3 squared is equal to 7. Hey, I got to take the square root of both sides. Oh, but 7 is not a perfect square. That's okay. We're just going to leave it in radical form. X minus 3 is equal to plus or minus the square root of 7. I can't split 7 up into factors that are perfect squares, right? So we just leave it as the square root of 7. And so we get x is equal to 3 plus or minus the square root of 7. And again, my two answers, my solutions, x equals, I'm going to have 3 plus the square root of 7, which you could put in, you could throw in your calculator and get the decimal if you wanted to. I would round to 2 decimal places. I'm not going to do that. I prefer the answers left as radicals, just my personal preference. And since for those of you who are taking this class with me, I write your tests and quizzes, you're going to want to do it the same way I do it. This is how I'll leave your answers on those tests and quizzes. Wow. Right, an extra little wrinkle, but not that big a deal. We just start by dividing everybody by whatever that leading coefficient is and force it to be a 1. Let's try a couple more. All right, well, looks like my leading coefficient in this case again is a 2. So let's go ahead and start by dividing everybody by 2. And we wind up with an x squared minus 7 halves x plus 5 halves is equal to 0. The 5 halves is not a perfect square. Move it to the other side. Awesome. Add your b squared over 4. And algebra says whatever you do to one side, you got to do to both sides. Sweet. All right, I think we can probably do this in our head at -7/2 is going to be my b. And I got to square it. Well, -7 times -7 is going to be a 49. 2 times 2 would be a 4. I drop that 4 into the bottom, and I'd have 4 times 4, which would be 16. So how about 49/16? 49/16 is not going to reduce. All right, here we go. That's negative, so both sides are going to have to be negative. Let's see, I get a 49 by doing 7 times 7, and I get a 16 by doing 4 times 4, so 7/4. Awesome. That's all going to be equal to -5/2 plus 49/16. Your common denominator would be 16, so you'd multiply top and bottom by 8, or you could just use your calculator, and you would wind up with 9/16. Oh, I love it. 9/16 is, both of those are perfect squares. Here we go. Take the square root of both sides, plus or minus the square root of 9/16. But, like we just said, both 9 and 16 are perfect squares. So when you take the square root of them, remember you can take the square root of the top and the square root of the bottom separately, you wind up with 3/4. So plus or minus 3/4. Add the 7/4 to the other side. And actually, we're going to go ahead and get our answers. Let's do this. 7/4 plus 3/4. Well, I need a common denominator in order to add fractions, and I already have a common denominator. My common denominator is 4. So just add the numerators. 7 plus 3 would be 10/4, which I can reduce to 5/2. Awesome. Then I'm going to do 7/4 minus 3/4. Again, to subtract fractions, I need a common denominator, but I already have one. It's 4. So it'd just be 7 minus 3, which would be 4. So I'd wind up with 4/4, which is 1. Oh, yeah. Awesome problem. So there's my 2 roots. Here we go. Let's do another one. Okay. Got to divide everybody by 3. And we're going to wind up with an x squared, x squared plus 10/3 x. You know what? Let's just move that. It's a negative 8/3. We'll move it to the other side, make it a positive 8/3. Sorry, I'm skipping a few steps here, but I think you guys are probably okay with it. You should be. We have done so many of these at this point. In fact, let's just go ahead and add our b squared over 4. 10 squared is 100. 3 squared is 9. 9 times 4 would be 36. So you'd have 100 over 36. 25/9. And algebra says whatever you add to one side, you got to add to both sides. So that's my b squared over 4, 25/9, which hopefully you guys are getting pretty good at doing those in your head. Certainly something that you should be able to do as mental math. And feel free to use your calculator if you don't feel comfortable with it. And actually, this works out pretty easily. I need a 5 and a 5 and a 3 and a 3, and they both got to be positive because that guy's positive. Oh, sorry. So it's going to be 5/3 plus 5/3. And then I wind up with 8/3 plus 25/9, which is going to be 9/16. Yeah. No. Sorry, not 9/16. Nope, 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 nope. 49/9. Yeah, there we go. Both of which are perfect squares. I like it. So we're going to take the square root of both sides, and x plus 5/3 is going to be equal to plus or minus. When I take the square root of 49, I get 7. Square root of 9 is 3, so 7/3 plus or minus 7/3. Subtract the 5/3 to the other side. And let's get our two answers. Negative 5/3 plus 7/3. I already have the common denominator. Negative 5 plus 7 be 2/3. 2/3. And a negative 5/3 minus 7/3 is going to be, all right, so negative 5 minus a minus, or I'm sorry, negative 5 minus 7 would be a minus 12, but we're dividing by 3, so how about a negative 4? Hey guys, that is really good mental math. Well done. Awesome. Next page, I got one more for you here. Let's go ahead and do this one too, since we are on a roll. Divide everybody by 3 because I need that leading coefficient to be a 1, and it is not. So we're going to make it a 1. But that's going to wind up giving me 14/3 x. Add the 16/3 to the other side. Let's add a b squared over 4. Okay, so 14 squared, 3 squared, 9, 36, 49/9. Yeah. Okay, x and x. I like it. It's going to be 7 and 3, and they both got to be positive because that middle term is positive. So plus 7/3 and plus 7/3. And 16/3 plus 49/9 should be 97/9. Yeah, I don't think that's going to come out. 97, I don't think, I'll have to check my calculator. Maybe we'll be able to split that up into something, into factors where one of them is a perfect square, but I don't know. Anyway, we've got x plus 7/3 squared. Go to 97/9. We wind up with, take the square root of both sides. Okay, I can take the square root of 9, but I can't take the square root of 97. So I'm going to leave it as the square root of 97/3. Awesome. Negative 7/3 plus or minus the square root of 97/3. And at this point, I'm actually going to have to stop there because the square root of 97 is going to be an irrational number. And I don't want decimals, right? So I'm actually going to have to leave my answer like that. So your two answers would be negative 7/3 plus the square root of 97 divided by 3, then a negative 7/3 minus the square root of 97 divided by 3. Guys, that takes care of all these problems where we add that extra little wrinkle where your leading coefficient is not a 1, and what you do to force that leading coefficient to be a 1 so that you can then complete the square. Head on over to the next page of the notes and we'll take a look at another little wrinkle that might show up when doing completing the square problem. So head on over to the next page of the notes and I'll meet you guys there.